All right, so now we're moving on to the muscular system. So what you'll see again, essentially in the body, we have 3 different types of muscle tissue. They're all going to have slightly different properties, look slightly different, but the general way that they function generally the same way. Okay, so at the top you'll see skeletal muscle. Then we have what can be called smooth muscle. Here it's labeled visceral, but the most common way you talk about smooth muscle, you call it smooth muscle. And then cardiac muscle, which is only found in the heart. Each of these are going to have very specific roles, and again, their functions are their physiology, I should say, is slightly different based on their very specific functions. So looking here, you're going to see some of the most common muscles in the body. You'll notice, based on this chart down here in the bottom right of the slide, the muscles tend to be named in a certain way, right? So they can be named based on their shape. This is very common with a muscle like the deltoid. It can also be called based on location. So if you look at vastus lateralis, it's a lateral muscle, right? Which leads us into another idea, the size of the muscle. So vast, large or wide. Vastus lateralis is a vast lateral muscle, right? Next, very easy to learn is actually when they're named based on what they do. So you'll see in the groin area, you have adductor longus, right? There's also an adductor brevis and an adductor magnus, okay? We also have muscles that are named based on the number of origins, right? So a muscle like the biceps brachii actually has 2 heads to it, all right? There's a long and a short head, all right? So bicep indicates 2 heads. You also have triceps. There's 3 heads to the triceps. There's a long, medial, and lateral head, right? But we also have a bicep femoris, which is one of the hamstring muscles. We can also talk about the way that the muscle fibers run. That's a little more rare, but you talk about like the external or internal abdominal oblique muscles. So overall, these are going to be relatively easy for the most part to name because they're going to be named on something for something, okay? Tendons, again, important to know that tendons connect muscle to bone, whereas ligaments are bone to bone. Fascia is a term for connective tissue that covers not just muscle, but covers muscle as a kind of protective sleeve, holds things in place, all right? So, again, looking at the different types of muscles, they're going to look different. They overlap in different ways, but the important thing for you to remember is generally where they're found. So skeletal muscle, obviously in the skeletal muscles. Smooth muscles going to be within the body, typically inside organs, blood vessels, etc. And it's non-controllable by, it's not actively controllable. And then cardiac muscle, only in the heart, and again, not actively controllable. So with muscles, the important idea is just to remember that they have actions, right? Essentially, you have the origin and the insertion. So the muscle fiber goes from one spot to another. You can also call it like a proximal or distal or a medial versus lateral attachments. Doesn't really matter all that much. But essentially, the muscle will bring the origin and insertion closer together, right? So if you're looking at here, the muscle of the forehead, that's called frontalis. It's going to raise, it helps you wrinkle your forehead. You can also draw the scalp backwards with it as well, because it's a little more complicated, but the frontalis is actually attached to another muscle at the back of the head, and they kind of can work together. So actions of muscles, this is important. This is how you describe what a muscle does. So essentially, we have flexion. You can think of flexion as generally shortening a joint angle, right? Extension is going to be increasing a joint angle. Abduction is going to bring something away from the midline. You can think about it as like an alien abducting you, right? If your alien's abducting your arm, it's bringing it away from the midline, right? So you would be bringing your arm essentially straight out from your body. A deduction or adduction is the exact opposite. It's bringing it closer to the midline. Rotation. So rotation is actually movement in the transverse plane. Dorsiflexion is specific to the ankle, and dorsiflexion is going to occur when you move the ankle in such a way that the toes are going to face more towards the sky. You have plantar flexion, which again applies to the ankle. That's going to be when you would stand on your toes or flex in the plantar direction, and plantar is bottom of the foot. And dorsal part of the foot, which would be, you could also call like the top of the foot. Supination, pronation. Now, supination and pronation can apply to both the wrist and the ankle. Supination is, again, going to be involved in the standard anatomical position where the palms face up or out. Pronation is the exact opposite, so a palm would face down or posteriorly. Now, with the ankle, we don't typically call it supination or pronation, but you call it inversion or eversion. So supination is the same as inversion, and pronation is the same as eversion. So supination and inversion would be essentially making one foot, the plantar aspect of one foot, face the other foot. And pronation or eversion is the exact opposite, where you would try to make the bottom of the foot face laterally. So you see here descriptions of what these actions look like. And again, I went through these already. So terminology. Fascia, fibro, fibrous. Leomyo is something that's actually not very commonly used. It's going to indicate specifically smooth muscle, whereas myo in general just indicates muscle. Myocardio is heart muscle, so you might see something like myocarditis. Myoso, again, another term for muscle. Planto, sole of the foot. Rhabdomyo is skeletal muscle that is connected to bones. You might see something like rhabdomyolysis. Asthenia, or lack of strength. And then trophy, we see like an atrophy or hypertrophy. So trophy, if you combine with the prefix a, atrophy would actually be the exact opposite of the meaning here. So a essentially means without. So you would be saying without development, without nourishment. And we typically describe atrophy as muscle wasting, right? And you can talk about other tissues atrophying as well, like the dying tissue atrophies. Now, hypertrophy is overdevelopment, overnourishment. You talk about hypertrophy in a case where, like hypertrophy of the left ventricle occurs in certain cardiac conditions that are not very good for you. So the left ventricle of the heart is going to become larger in a non-beneficial way. Again, we look at terminologies, AB or AB, away from, AD or add is toward. And again, I exaggerate the AB versus AD because when you say them normally, like abduction or adduction, if you're talking quickly, it's beneficial to ensure that you're communicating your message across effectively. Dorsey is back. Poly, another important one. Most people probably already know this, but it just means many. Electromyogram is a examination of muscle function. These are pretty cool because essentially what happens to make muscle contract is your neurons, the nervous system, is essentially connected to your muscle, and they send an electrical impulse. It causes some chemical gradients to change, primarily involving sodium, potassium, and specifically within muscle, you're going to talk about calcium being important as well. But it's going to cause some changes in those concentrations within cells, and it allows what's called an action potential, which is essentially just a message being sent from the nerves to the muscle. What you do here is you can essentially stimulate a muscle. You can you stimulate the muscle. You can monitor the electrical activity reaching the muscle, things of that nature. It's a very beneficial tool, especially when you're looking at the interaction of the neuromuscular interaction.